Yeah, so recent polls have kind of been showing that the public is increasingly more skeptical about climate science and global warming. And so this presentation is basically just the state of the climate science with keeping these kind of skeptical arguments in mind. So just a quick outline, I'm going to make a quick couple points on the difference between weather and climate. I'm going to talk about the most recent observations that we have available to us. I'm going to go through the evidence for humans' influence on climate. I'm going to touch on the climate research unit emails, also known as ClimateGate. I'm going to take a look at an error that was found in the IPCC report that has gotten kind of a lot of media attention, and also just touch on what is meant when people kind of say consensus when they're talking about climate change. So just a quick point on weather versus climate. Your weather locally is not a very good indicator of what the climate is doing globally. And last winter was a very good example of this. So this is temperature anomalies for December through February, December 2009 through February 2010. And the United States and Europe had pretty cold winters. The United States actually had the 18th coldest winter in the instrumental record. But globally, the warmth far outweighed the cold, and it was actually the 5th warmest winter globally in the instrumental record. Another point on weather versus climate is that weather will always kind of introduce variability on top of climate. So you're always going to have, record highs and record lows. And what this graph is showing is the ratio of record highs to record lows in the United States over the second half of the last century. And as you can see in the 80s, the ratio of record highs to record lows was 1.14 to 1. In the 90s, it was up to 1.36 to 1. And in the 2000s decade, it was actually over 2 to 1 record highs to record lows. But the point is you still get record lows. That's just weather. Okay, so looking at kind of some of the most up-to-date observations, this is a reconstruction of temperature from NASA. As you can see, there's been significant warming throughout the instrumental record going back to 1888. And so I don't know if you guys followed this at all last year, but there were kind of a lot of media reports about how global warming had stopped and how the temperatures had actually been cooling for the last decade. And so what people were doing when they were saying this is they were taking the years 1998 and 2008 and basically drawing a line and cherry-picking data and saying that global warming has stopped and cooling has begun. And when you look at the context of warming throughout the whole record, you kind of see how silly this is. And you could have done this at any point throughout the whole record. The 90s were cooling, the 80s were cooling, the 70s were cooling. You can do this at any point when you have a noisy record of any kind. So when you're talking about something as important as the globally average surface temperature, it's good to have different kind of estimations of how this is progressing. And so this is a plot showing the 5 major temperature reconstructions. 2 of them are satellite, which is University of Alabama, Huntsville, and remote sensing systems. And the other 3 use meteorological stations as well as satellite data for ocean surface temperatures. What you can see is that there's some disagreement from year to year. The satellite record, by the way, only goes back to 1978. So there's some disagreement from year to year, but the overall trends are very similar. And so this gives us pretty good confidence that we kind of have a good idea of how the temperature is changing. So other than actually measuring the temperature, we can infer global warming from other pieces of evidence. One thing to look at would be cryosphere changes. This graph here is showing a gravity satellite measurement of ice mass for the Greenland ice sheet as well as the Antarctic ice sheet. And this project, this is from the GRACE satellite. This started in 2002. And what they've seen since they've started measuring this is kind of an accelerated loss of ice mass. And And they measure this from flying satellites over the ice sheet and actually measuring the gravitational pull that the ice sheets exert on the satellite. Another way, another kind of piece of evidence is total glacier loss. So this is a plot of the total cubic miles of glacier volume that we've seen an accelerated decline in glacier volume since 1960, down over 2,000 cubic miles. Other ways of measurement, we can look at global heat content of the ocean. This is measured from satellites, and it's also measured from floats. There's all these, there's like thousands of these floats, they're called, out throughout the ocean that are kind of taking the temperature of the ocean and just floating around, and then they, beam up their location to satellites. And so we can see a large rise in total ocean heat content. Kind of going along with that would be sea level rise, because sea levels are rising both because we are losing ice mass and also because the thermal expansion of the ocean itself. And so we also see acceleration of sea level rise in recent years. So just kind of a summary of that. 2009 was the second warmest year to the fifth warmest year, depending on the reconstruction you use in the instrumental record. The 2000s was the warmest decade on the record, no matter what reconstruction you use. The upward trend in temperature is basically unmistakable. We can measure it from meteorological stations, we can measure it from weather balloons, we can measure it from buoys and ships, satellites. It can be inferred from glacier melt, sea ice, or ice sheet melt, sea level rise, changes in the seasonal cycle, like the date when the snow melts on average in various regions, and also from changes in the biosphere. So moving on to humans' influence on the climate. So this is just this slide is just kind of a really brief history of kind of the pioneers of the greenhouse effect on, the discovery of the greenhouse effect and how it's influenced climate. In 1861, John Tyndall published the first research showing that the heat trapping property of gases. In 1896, Svante Arrhenius published the first research on carbon's effects on surface temperature. And so this is the paper, and I just thought this was cool. Like, you're talking about 1896, and it's called The Influence of Carbonic Acid in the Air Upon Temperatures on the Ground. And so this is an idea that's been around for a very long time. There's been a lot of science accumulated on it. Then in 1975, Wallace Broecker published kind of a landmark paper, one of the first to use global warming. Right here in the abstract it says, if man-made dust or aerosols is important as a major cause of climate change, then a strong case can be made that the present cooling trend will, within a decade or so, give way to pronounced warming induced by carbon dioxide. And this turned out to be an incredibly accurate prediction.